Welcome students. Today we discuss the convergence of series summation k starting from 2 to infinity 1 upon k square minus 1. If we test this convergence by nth partial sum method by taking limit on a sum of first n terms of this series. So first I decompose this sum, general term of the sum, by partial fraction method. 1 upon k square minus 1 can be written as 1 upon k plus 1 into k minus 1. This can be written as a upon k plus 1 plus b upon k minus 1. Now we multiply both sides by k plus 1, k minus 1, which implies 1 is equal to a into k minus 1 plus b into k plus 1. Now first we put k equal to 1, putting k is equal to 1, which implies 1 is equal to 0 plus 2b, which is equal to 2b, which implies b is equal to 1 upon 2. Again we put k equal to minus 1. So putting k equal to minus 1. Putting k equal to minus 1, we get 1 equal to minus 2a, which implies a is equal to minus 1 upon 2. Now 1 upon k square minus 1 is equal to, value of a is minus 1 upon 2 minus 1 upon 2 upon k minus 1, k plus 1 plus 1 upon 2 k minus 1. This can be written as 1 upon 2 is taken as a common, and first I write second term, which is 1 upon k minus 1 minus 1 upon k plus 1. Which implies this is the value of 1 upon k square minus 1. Now for nth partial sum, we take sum of first n terms. So taking limit summation k starting from 2 to n, 1 upon k square minus 1 is equal to summation k starting from 2 to n, 1 upon 2, 1 upon k minus 1 minus 1 upon k plus 1. Now this can be written as 1 upon 2 summation k starting from 2 to n, 1 upon k minus 1 minus summation k starting from 2 to n, 1 upon k plus 1. This is equal to 1 upon 2. Now summation k starting from 2 to n, 1 upon k minus 1 can be written as summation k starting from 1 to n minus 1, 1 upon k. Now both these series are same. Here k varies from 2 to n, and in this case k varies from 1 to n minus 1. And general term 1 upon k minus 1 becomes 1 upon k. So both these series are same. The second series remains same, summation k starting from 2 to n, 1 upon k plus 1. Now we expand both these series. 1 upon 2. First series becomes, first term is 1 plus 1 upon 2 plus 1 upon 3, 1 upon 4, up to so on. Last term becomes 1 upon n minus 1. The second series becomes, here k varies from 2 to n, so first term is minus 1 upon 3 minus 1 upon 4 up to so on. Here last term becomes 1 upon n plus 1, 1 upon n plus 1 minus 1 upon n plus 1. So second last term becomes minus 1 upon n, and third last term is minus 1 upon n minus 1. Now here we see that 1 upon 3 minus 1 upon 3 cancel out, 1 upon 4 minus 1 upon 4 cancel out. Similarly, all the terms from 1 upon 3 to 1 upon n minus 1 cancel out with all these terms. So we left with the terms 1 upon 2, 1 plus 1 upon 2, and last two terms of second series, which is minus 1 upon n minus 1 upon n plus 1. This is the value of summation k starting from 2 to n, 1 upon k square minus 1. Now we take limit n approaches to infinity, which implies limit n approaches to infinity, summation k starting from 2 to n, 1 upon k square minus 1 is equal to limit n approaches to infinity, 1 plus 1 upon 2 minus 1 upon n minus 1 upon n plus 1. After applying limit, we get here 1 upon 2 is common, so we get 1 upon 2, 1 plus 1 upon 2 minus 0 minus 0. Anything by infinity is equal to 0. So this is equal to 1 upon 2, 1 plus 1 upon 2, 3 upon 2, and this is equal to 3 upon 4. So this series converges to 3 upon 4. Thank you for watching this video.